30%. That's how much ocean acidity has increased from the pre-industrial era to 2024. The most concerning factor? This is only projected to grow in coming years.
Of course, with the problem so grave, there are already methods of reducing atmospheric CO2 levels already in place, notable ones being retrofitting engines and large-scale CO2 scrubbers. However, rollout of these devices is often economically infeasible and are therefore not justifiable for profit-driven corporations.
But what if there was a way to overcome these restrictions? What if we could reduce CO2 and local ocean acidification in an affordable manner without altering port activity and infrastructure?
We are Frontline. We are revolutionizing carbon capture and reduction in coastal cities with Coastal Converter. Coastal Converter directly reduces coastal atmospheric carbon dioxide levels by attaching to the exhausts of port vehicles and machines. Contrary to contemporary carbon capture, which require massive centralized facilities, our devices clip onto existing infrastructure, such as cranes, equipment, and docked ships, which ultimately allows carbon capture to scale affordably and gradually.
The center of Coastal Converter is a high-flux hollow fiber membrane. Exhaust gases from port vehicles flow through thousands of thin hydraulic fibers designed to selectively separate carbon dioxide from other gases. Because CO2 is more permeable through the membrane than nitrogen or oxygen, it passes through the membrane at a much faster rate while the remaining gases exit normally. In particular, our membranes are semi-permeable isoporous membranes, meaning the pores are evenly spaced and uniform in size. This allows for smoother gas flow, less resistance, and more precise control over the membrane layer. As a result, CO2 transport is significantly higher than conventional commercial membranes, while requiring less material.
To evaluate the feasibility of our approach, we consulted Professor Ryan Lively, a faculty member at the School of Chemical and Biomolecular Engineering at the Georgia Institute of Technology, and a leading expert in membrane-based gas separation technologies.
On the membrane side, we know it works. It's been demonstrated at large scales. The membrane side will absolutely work. It'll make you nice, pure CO2.
Then, a compact vacuum pump gives us the driving force to separate CO2, allowing the device to be energy efficient with a limited footprint and few hazardous chemicals being involved, since the vacuum removes the gas from inside the fibers.
This carbon dioxide then reaches one of two locations: a replaceable cartridge where it is stored, or into a CO2 pipeline system leading to an underground CO2 storage.
Coastal Converter enables the expansion of CO2 pipeline infrastructure by connecting our CO2 cartilages to collection centers through low-pressure standardized transfer lines.
Yeah, I mean, the nice part about a port is usually where there's a port, there are pipelines. And depending on where you're imagining using this, there's also going to be a CO2 pipeline.
Coastal Converter's use of pipelines will permit CO2 transport and utilization networks into coastal regions beyond its current concentration in the Midwest and Gulf Coast of the United States.
Using CO₂astal, a process simulator, we analyzed coastal water chemistry data sourced from local ports and modeled the impact of Coastal Converter on California port regions. Our results indicate an estimated 35.6% reduction in local ocean acidification rate within port environments. As development scales, this impact is only expected to grow.
On the other hand, our current competitors are deploying large-scale carbon capture plants, offshore carbon sequestration, and direct air capture.
We believe Coastal Converter provides a novel solution since it is modular, port integrated, low energy, and immediately deployable, filling the critical gap between industrial scale capture and emerging direct air capture technologies.
I very much like the idea of membranes for CO2 capture at harbors. That's a good idea. And so if you are in a sort of tight, confined space like a port, you're not going to put a giant CO2 capture system. You want something miniature and small.
Key revenues would be generated through direct sales to port authorities, terminal operators, and shipping companies. Additional revenue opportunities include long-term maintenance contracts, membrane replacement subscriptions, as well as licensing of the system design for international ports that implement Coastal Converter. The port equipment industry is estimated to surge to an evaluation of $33.1 billion by 2034, with significant potential for future growth as more of the developing world engages in international commerce.
With around 4,500 large-scale ports internationally, assuming final adoption of 10 units per port at a unit price of $1,299, it represents a $58 million revenue opportunity. Additionally, with the membrane replacement service of around $200 contracted to occur once every 3 years after initial sale, we can expect another $3 million in revenue annually.
The journey to reducing carbon dioxide levels has struggled for years due to a lack of affordable solutions and an infrastructural inability to support large-scale renewable energy and carbon capture. Together, we have the ability to change the lives of billions of humans and animals today. We are Frontline, and we look forward to working with you in solving the problems of the future together.